What time is it? It's science time.
Science time. Let's all stop and just unwind. 1, 2, 3, 4, here we go. Learn so much your brain explodes. Lessons so cool, so fresh. Beat so big you'll lose your breath. Learning facts and real cool stuff. Scream for more, can't get enough. It's science time. It's fun, you best believe. Explore and learn new things. Come and join me, please.
I'm Mr. C, and this super smart group is my science crew. Lila is our notebook navigator, Alfred is our experiment expert, Riley is our dynamite demonstrator, and London is our research wrangler. Working with my team is the best and makes learning so much fun. Actually, you should join us. Today, we're learning about optical illusions. What time is it? It's science time. Welcome back to another episode of DIY Science Time. I'm Mr. C, and I'm so glad that you're here to be part of our crew today. We are talking about optical illusions. That's right, things that make our eyes and our brain say, "What is happening?"
What?
And look, I have one right here for us. I've got a blue card and a red card, and they're sitting there, and you're looking at them, and I want to ask you, which one appears to be closer to you? You have one? All right, see if you're right. Did you expect that to happen? Doesn't it look like the red card is in front of the blue card? Well, it's an optical illusion because the cards are not in front of each other like you thought originally. The red card is actually behind it, but I have this corner cut out to make it appear like the blue card is behind the red card. I have another one for you too. I've got these cards right here. I've got a special deck of cards. And these three cards, let me just show you. On top, I've got a DIY science card. I'm gonna take that DIY science time card. I'm gonna put it on the bottom. Snap my finger, and I have a DIY science time card. I'm gonna take that DIY science time card. I'm gonna put it on the bottom. Oh, I snapped beforehand. But look, it popped up front. I'm gonna flip it over. I'm gonna take that card, put it on the bottom. There you go, it's on the bottom. It's on the bottom. There's another one. And I know what you're thinking. Mr. C, there are 3 DIY Science Time cards. Well, let me show you something. There are actually no DIY Science Time cards. How did I do it? Well, it's a little bit of science and magic trickery, but we're gonna be talking about optical illusions today so we can have more fun tricking our brains into seeing and believing things that may not actually be true. All right, Alfred, what do we need for materials today?
Don't let this short list of supplies trick you. Today's activities are going to be lots of fun. You'll be able to create some amazing optical illusions with just these simple materials. Some plain white paper, a ruler, a pencil, colored pencils, scissors, and of course, our science notebook.
A science notebook is a tool that every scientist should have, and it gives us a place to record all of our learning. Taking good notes and being organized allows us to be better scientists. A science notebook allows us to go back and review all the data and information we've gathered during our experiments. Plus, it allows us to share results with other scientists who might be interested in learning more about what we've discovered. Whenever you see the notebook pop up on the screen, like this, it's a reminder that this is a good place for us to jot down new information. You can see I've already added a title and a list of materials for today's activity. Our crew is still going to have lots of information to collect and organize as we go through the experiment, so keep your notebook handy. Most importantly, the more you use the science notebook, the better you'll get at taking notes and recording data. If you don't have a science notebook yet, download a copy of Mr. C's science notebook from the website.
I've already got started. Check out this drawing I have. Isn't that amazing? It looks like it's a 3-dimensional drawing when in fact, it is a 2-dimensional drawing that's literally just sitting there on the paper. But the way it looks, it appears like the person is popping up off the paper. We call that forced perspective. It's kind of tricking our eyes and our brain into seeing something that really isn't the case. So I want to show you how to do that. because there's something really unique about this drawing that if you look at it closely, you'll notice the head is really big, the body is relatively small, and we have this fake shadow here to give the illusion that the character is standing up and light is coming down from above. So, are you ready to draw a character with me? Let's do this. Start with the head. I want to make the head really big. I'm going to give some big ears, some really big eyes, a nose, a point on the bottom. All right, there's our head. And now I'm going to make the body, give him a waistline, some human legs. Now, we're going to make this so his arms are tucked in, so we don't have to cut around the arms. I'm going to quickly trace over my lines. I'm gonna erase this out of his ear. Gotta finish his other eye. And now we color him in. All right, so now what we have to do is we have to give him a shadow also, because if we have light coming from above, the light is, if it's pretty direct, it's gonna be a short shadow. So I'm gonna go just sketch out the shadow. I'm gonna put a circle here to represent kind of the head. And the shadow is going to be darkest by our character's feet. And what we're going to do then, just take our finger, we're gonna try to blend that shadow a little bit to get rid of the lines. All right, now we need to cut our character out. We're gonna take our ruler and about halfway down, just right over his waist, I'm going to draw a line, and now I'm going to cut everything out from up here, above the line. All right, so I've got my character. Welcome to the science crew. Let's see if he pops up off of the paper like our other character did. So we're going to set this down. Put this, oh, that's so cool. All right, I'm gonna grab my camera so you guys can see it up close. And you can actually see the character popping up off of the table. How awesome is that? Force perspective. Force perspective allows us to create this character and have the character pop up off the table. Give it a try, have some fun, force your family and friends to do this activity with you. It's a great optical illusion. Optical illusions are things that deceive our eyes by appearing to be something other than what is there. Our eyes are used to seeing the world in a certain way, so when we change that, our brains try to process and make sense of this new information. Look at this window. Like many people, you're probably seeing the window swinging back and forth. But what if I told you that this window was actually spinning in a circle? Don't believe me? Look again. This is an Ames window. Adelbert Ames Jr. invented this and discovered it in 1947. What I love about this illusion is that it really makes us think about what it is we're seeing. If I take this off for a moment, you can see that we have ourselves a window. This window isn't the typical rectangular shaped window that you are used to seeing at your house or in different places. Instead, it's a trapezoid. This side is longer, this side is shorter. It's also colored in and shaded in a way that it makes it appear like there is light hitting the window. So when I put it back onto our turntable, it'll start spinning. And when it starts spinning, you'll see it oscillating. So it looks like it's going back and forth, back and forth. Most people don't believe that it's actually spinning in a circle, and that's because it's an illusion. Our eyes are playing tricks on us. We're always used to seeing rectangular windows, so our brain is telling us, well, it has to be a rectangle, it looks like a window, and it's spinning back and forth. That's what it is. That's what it does. But let's try something else. I'm gonna take this off for a moment, and I have this little cube that I made, and I colored it, and I'm gonna put it right on the front of our window. Now I want you to pay attention to what happens to the cube. This is going to definitely allow us to make sure that this is spinning in a complete circle now. See if you can see it. Can you believe it? The cube looks like it's going through the window. It appears as if the window and the cube are intersecting. It doesn't look like the cube is going in a circle. It looks like it is pivoting back and forth. All right, I've got one more. Let's give this a try. We're gonna take this off. And I have a straw here. We're gonna put the straw right down the center through the window so that we can definitely see. And do you see it? The straw and the window continue to intersect. That's so awesome. This optical illusion is very popular, and it's one that you can actually build also by creating this window and building it where you can trick friends and family into seeing something that isn't actually there. So this trapezoidal window makes us think it's spinning back and forth like this, when in reality it was spinning in the circle the entire time.
If these illusions have your eyes feeling a bit out of shape, then it's definitely time to build a Schulte table. The Schulte table was originally developed by Robert Schulte to study the properties of attention. Schulte tables can help improve your memory, attention, and peripheral vision. Plus, they're lots of fun. Take a sheet of paper and create a square. Divide the square into 5 equal rows and 5 equal columns. Randomly write the numbers 1 through 25 on your table. Here's the question. Do you think you can locate the numbers in order in less than 30 seconds? Let's find out. 3, 2, 1. You have 15 seconds left. Time's up. How high were you able to count? Did you get to number 25? Make a few different Schulte tables to test friends and family in your science crew.
You want to see another super cool optical illusion? It's actually animation, or cartoons in motion. That's right, when we look at cartoons on TV, those cartoons are typically drawn one frame at a time. When we put those frames together, they create this amazing motion. Check this out. I created a flip book to show you one of my newest and latest and greatest stories. It's called Bouncy Ball by Mr. C. What I love about this optical illusion is that the ball starts in my hand, I pull my hand out and the ball drops, splats on the ground, and bounces back up into the air. Now you might be saying to yourself, how do I do this? It's super simple. You draw one frame at a time, make small adjustments, and then you animate it by putting it into motion, by flipping through those pages really quickly. So, first thing you're gonna do is take a sheet of paper. I have these index cards. It can be a sheet of paper that you cut into half. They don't have to be big like this. All you want to do is make sure that they're the same size essentially so that your flip book will be able to flip easily. I'm actually going to create a dropper this time. Now, the trick with this is you have to take the next piece and you're going to draw essentially the same thing. I'm gonna take that drop of water and just have it come out just ever so slightly. And I'm gonna do that again. Now, as you can see, this is not a very complicated animation. It's actually really simple, but it takes a lot of work to get my water droplet to fall down to the ground. Out. Nice and flat. Now what you do is you take it, oh wait a minute, it's backwards. So I need to reverse the order. So I'm gonna put that one down. All right, so here is our start. I'm going to get it ready. Here we go. All right, here we go. Mr. C's water drop. Oh, that was awesome. Did you see the motion? The water dropped out. Splat. That's an animation. We created an animation, which is essentially an optical illusion. We're taking these still frames, putting them together really quickly, causing our brain to think that something's actually moving, and that is an optical illusion. You have to try this. I can't wait to see all of your drawings. Hashtag DIY Science Time.
Here is your task. Do not read the words that I'm going to put on the screen. Instead, only say the color of the words. For example, if the word green is printed in blue, you would say blue. Are you ready? Let's go. 3, 2, 1. Great job! Was it more difficult than you thought it would be? You just experienced the Stroop effect. J. Ridley Stroop discovered this phenomenon in the 1930s. The color is hard to say because your brain is trying to process two separate things at the same time. Your brain has to decide if it focuses on the word or the color it sees. I wonder if we tried the same words but started it at the bottom. Do you think it would be easier or more difficult? Let's try it. 3, 2, 1. Great job! Was it more difficult than you thought it would be?
I want you to take a look at another image for me. This image, tell me what you see. Do you see the vase or do you see the face? Faces. This here is the Rubens vase. Edgar Rubin was a Danish psychologist who actually developed this as he was exploring negative space in artwork. The idea is this: when you look at that image, you either see the vase that pops up to the foreground with the faces in the background, or some of you may see the faces pop to the foreground and the vases in the background. Either way is a-okay, but it's an optical illusion and it's just how our brains work when we look at different things. Plus, the black and white contrast makes it very apparent that there are two different things on that screen. Well, on the paper. And this is what we're going to do now. We're actually going to build our own Rubens vase with a sheet of paper. So grab yourself a sheet of paper, fold it in half. Whoops, I have two pieces. And what you're going to do is you're going to draw a face or an outline of a face on one side. So I'm going to draw an eye. I'm gonna make a nose, and here's my mouth. I'm gonna come down, and I'm gonna make it like a box on the bottom. I'm gonna bring it over to the center. And here is my eyeball. I'm gonna bring it up a little bit and then just bring it straight across. Now, what makes a Rubens vase work is that it's symmetrical. That means both sides are equally the same. So I'm going to take my sheet of paper, I'm going to fold it in half, and I can actually see the outline on the other side. So I'm gonna trace that. I'm gonna try to get it as close as I possibly can. All right, so I'm gonna flip this back open. And now I can see my outline on this side, so I have to trace it one more time. Oops, too much. Made a little mistake. And now I have my vase, and you can see the faces. If I put an eyeball there and a nose and some teeth, you can actually see the face. Now we have to shade it in. So there we have it. We have our vase and our two faces. Can you see them? My face is like, rah! Make yourself a Rubens vase, explore this illusion with friends and family, and come up with great designs. I also wonder if this was a different color on the inside, would that impact the way we see the faces or the vase? So give it a try, explore, have some fun, and make your own Rubens vase.
Take a clear piece of plastic and draw lots of lines. Try to space the lines as evenly as possible, and then repeat the same pattern on a sheet of white paper. Now slide the transparent sheet of white paper and watch what happens. You've created a moire pattern. A moire pattern occurs when you take two repeating patterns and place them on top of one another. Try creating different shaped patterns to create all sorts of cool effects.
I've got one that you'll love. The spiral is going to start spinning in just a moment. I want you to stare at the spiral until I tell you to stop. Here we go. Keep staring at the spiral. We're almost done. I promise, we're almost done. Five, 4, 3, 2, 1. Now look at the face on the screen. Do you see it? This happens because we have 6 muscles in our eyes that work in pairs to move our eyes around in our eye sockets. While we're staring at the spiral, we tire out some of those muscles. Once the spiral stops, the rested muscles work harder and causes our brain to process the new stretched image.
All aboard! I've got another illusion to try. Look at this image of a railroad track. There are 2 straws placed on the tracks. Which one looks longer? If we slide the straws together, you can see that both straws are actually the same size. When the straw is placed towards the bottom of the track, the straw looks shorter, but when it's at the top of the track, it looks longer. The straw actually is the same size, but our brain uses previous experiences and the things we can see near the straws to try to figure out their size. Pretty tricky, right? This is called the Ponzo illusion, created by Mario Ponzo in 1911.
I've added lots of notes about these illusions and how we did them. Which one was your favorite illusion today? Ponzo, Stroop effect, Ames window? I thought these were all amazing. I also want to draw my own 3D pop-up cartoon. If you want to see more illusions or find printouts, you can always hop online and check it out on the website.
That's right, Lila. All of these optical illusions have my eyes and my brain flipping out. No, seriously. Flipping out. Get it? So if you don't already have it yet, make sure you get your science notebook downloaded so that you can keep track of all the tests and experiments that you are conducting. Specifically with these optical illusions, you want to make sure you have good notes because you want to be able to go back and say, is that what I actually saw happen? Because it can get very confusing with all of these different things. Whether we have these playing cards that are closer and further away, or our Ames window, our force perspective, or our moire patterns, optical illusions really make us see the world in a different way. So much fun. So much fun. Keep learning, keep having fun, keep exploring, and remember, science is wherever you are. See ya. We're talking optical illusions. That's right, things that take our different things than what's actually happening. I have one right here for you. I want you to take a look at this blue and green card. Oh, I said green. I said green card. It's red. I had to double check. It's an optical illusion. It's a red card. Yeah, it's working. Can you see it up top?